All right, hello once again, Jeff Scott of Rankin Technical College. And as part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD 1111.NET Framework with Web Databases class for the fall 2019 semester, I'm creating a set of video presentations based on the book for the class, which is Pro ASP.NET MVC 5, an A-Press publication by Adam Freeman. I'm working my way through Chapter 19 of 27, and we left off in the middle of page 550, Handling Unknown Actions. And the author says, if the action invoker is unable to find an action method to invoke, it returns false. When that happens, the controller class calls its handle unknown action method. By default, this method returns a 404 not found response to the client. So if we come back to our home controller and then down toward the bottom, we override the handle unknown action and we start the application and navigate to a URL that targets a non-existent action method. We should see the response that's shown on page 551. So let's give it a shot. Okay, caseness is different, but hopefully you get the idea. All right, I think it's because I put all mine in lowercase. All right, page 551. Improving performance with specialized controllers. The MVC framework provides two special types of controllers that can improve the performance of an MVC web app. Like all performance optimizations, these represent compromises, either in ease of use or in reduced functionality. All right. First, we talk here about sessionless controllers. By default, controllers support session state, which can be used to store data values across requests, which makes it easier for the MVC programmer. Creating and maintaining session state is involved. Data must be stored and retrieved, and the sessions themselves must be managed so that they expire appropriately. Session data consumes server memory or space in some other storage location and needs to be synchronized across multiple web servers. In order to simplify session state, ASP.NET will process only one query for a given session at a time. If the client makes multiple overlapping requests, they will be queued up and processed sequentially by the server. The benefit of this is that you do not need to worry about multiple requests modifying the same data. That's the upside. The downside is you do not get the request throughput you might like. Not all controllers, as mentioned right here, need session state features. In these cases, you can improve performance by avoiding work involved in maintaining session state. You do this by using sessionless controllers, which are just like regular controllers with two exceptions. First, the MVC framework will not load or store session state when they are used to process a request. And two, an overlapping request can be processed simultaneously. All right. Managing session state in our custom iController factory. At the start of this chapter, the author showed you that the iController factory interface contained a method called getControllerSessionBehavior. This returns a value from the session state behavior enumeration. That enumeration contains 4 values that control session state configuration of a controller, and they're shown on the bottom of page 551. Those being default, required, read-only, and disabled. The session state attribute is applied to the controller class and affects all of the actions of the controller. The sole parameter is a value from the session state behavior enumeration. In the example, the author disabled session state entirely, meaning that if you try to use the session state, like this, or try to read it back like this, the MVC framework will throw an exception. If you have specified the read-only behavior, then you can read values that have been set by other controllers, but you'll get a runtime exception if you try to set or modify the values. Bottom half of page 553, the underlying ASP.NET platform maintains a pool of .NET threads that are used to process client requests. This pool is known as the worker thread pool. The threads inside are worker threads. When a request is received, a worker thread is taken from the pool and given the job of processing the request. Once the request has been processed, the worker thread is returned to the pool so it's available to process new requests as they arrive. There are two key benefits of doing this. Number one, by reusing worker threads, you avoid the overhead of creating a new one each time you process a request. Number two, by having a fixed number of worker threads available, you avoid the situation where you're processing more simultaneous requests than the server can handle. All right, top of page 554, your server is capable of doing more work, but because you have tied up your resource threads, incoming requests are being queued up. You will be in the odd state of the application grinding to a halt while the server is sitting there basically idle. They mention a cautionary note here on near the top of page 554 where the author says, at this point, some readers may be thinking they can write their own worker thread pool. Don't do it. Writing the code is easy. Making it work is not. All right? The solution to the problem is the use of an asynchronous controller, which increases the overall performance of the application, but does not bring the benefits to the execution of asynchronous operations. As it says, they're only useful for actions that are I/O or network bound, but not CPU intensive. So let's take a look at the example that they have here, starting on 554. And we will do that in our next presentation.